Note that in this devlog video series, I will only be showing finished sections of the game. Since this is not a tutorial video on game design, there won't be any tutorials showing how I achieved the features. I have more than tripled the length of the BoBot design document since the first devlog video last month. I have been brainstorming new ideas and figuring out exactly what all of the features of the game are going to be. And the more that I play the prototype builds, the more ideas I get for what I want in the game. I test to see what works and just exactly how it is going to play. Prototyping is very important to game design. If there is not a clear identity and core mechanic to the game, then the developer will just end up wasting years trying out different things until something hopefully sticks. I have already been playing and fine-tuning my 2 prototype levels for more than 2 months, solidifying the actual game design, level design, and gameplay. I have been working on creating a minimum viable product for the past 2 weeks, so that I can get playtesting and feedback on the design. The story of the game is a brute robot named Brutus has taken over a high-tech facility. He is experimenting on plants and insects to create a race of superior beings to take over the world, and his robot minions will attack anyone who tries to stop him. BoBot is a lonely janitor robot that has been living in the basement of the building. Bo battles his way up through the floors of the facility, battling minion enemies that drain his power, and battling level bosses to get to Brutus in the final big boss fight. Each level is going to be a unique design, with the construction materials changing every 2 levels. Bo is a standard third-person type character with WASD movement and spacebar jump control. Bo also has some additional equipment, including a flashlight in his chest and an exhaust port that fires oil and gear parts out like a water cannon. Bo also has an additional movement system that is a spinning attack. During an attack by Bo on a boss, the boss may drop an invincibility shield, which Bo can pick up and be invincible for 5 seconds. The boss may also drop a multi-fire pickup that allows Bo to rapid-fire 5 rounds instead of 1. One of the big issues is determining how much complexity and difficulty is enough to make the game difficult but not impossible and frustrating. So I have been testing various level maze sizes to see what is a comfortable size to play. I originally had mazes as small as 5x5 and as large as 20x20. But I have settled on 6x6 through 12x12 as the sizes in the final game. A 5x5 maze is just too small and easy, and a 20x20 maze is really complex and frustrating to get through. The core mechanic of BoBot is the solving of the layout of the mouse mazes that get increasingly larger and more difficult as the player progresses. On top of this is a platformer game style where you pick up ammo, power, and special items, avoid or battle enemies, and solve a few puzzles. On top of this is a collectathon game style where you collect both stars and puzzle pieces. The stars are dropped by each level end boss when you defeat them, and the stars provide the player with additional power-up capabilities as they are collected. The puzzle pieces are located throughout the levels, and collecting at least 75% or more of the puzzle pieces will reward the player with an extra super boss fight at the end with Brutus. This means that gamers will have to search the maze to find the puzzle pieces in order to get to the final Brute main boss fight. I have spent the past few weeks getting the feel of the player controller just right. This includes the run speed, jump height, and additional controller features like coyote time and jump buffering. Prototyping is done on 2 early test levels to see how the gameplay feels. I increased the default jump height by 30%, and the coyote time is 30% higher than that. I also have the blueprint scripting completed for the player hose gun, the flashlight built into Bo's chest, and the spin attack on BoBot. The gun and flashlight and spin attack use up ammo and power, so it is imperative to collect as many of these pickups as you can in each level. Most of the main player pickups are now finished, except for the Niagara visual pickup animation effects. I have been learning Niagara since my previous Unreal Engine 4 emitter work was with Cascade, which is now deprecated. The pickups are designed with a base class with exposed variables that are adjusted for each individual child class. Pickups can only be picked up by Bowbot and are ignored by all other enemy classes. Some of the game instance global variables are now available, such as Bow's ammo count and power level, since those values are persistent across all levels in the game. My plans are to work on all of the blueprints and AI before continuing on with the rest of the level design, so that I have completed all game scripting using only my prototype levels. I have been thinking that for the AI of the basic enemies, that I would make them have a delayed search and chase with the ability to lose sight of the player. They also have variable walk speed, so that during roaming they slowly walk around, and then when they see you, they chase you at full run speed. This looks more natural than having the AI run during roaming. And for the boss AI, I want the bosses to have attack and retreat capabilities. I have only created 2 test levels so far, since I am basing the gameplay on those test levels. Before I go to the work of creating all 20 plus levels, I want to make sure that the gameplay is all ironed out and doesn't require any changes that may impact level design. I am using the damage system already built into the Unreal Engine 5 blueprints, as I felt there is no need to reinvent the wheel. However, I am using some custom overlap events for some of the minions for special attack types that are not directly supported by the damage system. Minions have the ability to pull power from Bow if they touch him, but only from the front. With Bow, I also decided that the player would not die and restart the level, or restart at a waypoint. Instead, Bow loses some ammo from his current inventory, which are used as ammunition in his enemy and boss battles. Plus, he loses a bit of power, which is used to power his flashlight and spin attack. The ammo and power are global variables that persist across all levels, instead of starting each level with a preset ammo and power amount. So by roaming every corner of every maze level, Bow can build up a massive amount of ammo and power for the battles. Bowbot's power level also partially recharges, so that he always has some power for one spin attack and for a few seconds of flashlight use. When Bow's power level reaches 0, after a few seconds it will recharge back to 1. I am currently looking into a method to get the minion enemies to roam when not in idle or attack mode, but in such a way that they are pacing between 2 defined locations. Something like how the minion enemies in Super Mario bounce back and forth between 2 spots in the level. I don't want simply random roaming that most people employ. I want the minion to stay close to their initial or last location. I have also been working on traps and puzzles and other game events. Since Bow cannot die or respawn at waypoints, I have to make sure that there's no places that he can get stuck, which would force a gamer to quit to the menus. So every trap must have at least one guaranteed way out. The level design in Bowbot is all indoor levels. This allows for more complex level design with considerably more meshes in the map, since occlusion culling will still allow for greater performance on low-end computer systems. On my R9 5950X 128GB RTX 3080 system, I get a solid 130 frames per second at 2560 by 1440. On my i3 12100 16GB GTX 1650 system, I get a solid 40 frames per second at 1920 by 1080. What I am working on now is the animation blueprints for bosses, along with the AI behavior trees. I will require at least 2 AI behaviors, as there are both stationary and moving boss characters. An example of the stationary bosses is the large carnivorous plant in the plant levels. It can attack, but it cannot walk. I still require another 8 or so minions, and most of them have custom skeletons and animations. That will require the creation of custom animation blueprints and blueprint classes. I also am using placeholder particle effects and sounds for now for many of the features, so those have yet to be created. I am testing out additional traps and obstacles to see what works and what feels bad. I will probably end up creating a lot of objects that later get cut from the game if I can't fit them in smoothly. I tend to look at and study other platformer games, see what they are doing for tricks and traps, and then design something similar that fits into the world design of Bobot. The Bobot game is custom assets for all of the level design created by myself, with props and characters from free sites or retail sites. All of my mesh assets have an alphabetical character at the end of the file name and not a number. Otherwise, the Unreal Editor's auto-naming system creates messy numbers at the end of the actor name in the outliner. Adding or duplicating assets causes an incremental asset number to be appended to the actor name, and that gets really messy if you use numbers at the end of your assets. Pickup textures are 512 by 512 with diffuse, normal, metallic, roughness, and specular. The metallic, roughness, and specular are packed into one RGB bitmap in BitPlane's RGB. I use the BitPlane Creator tool in TerreSculptor to pack my textures, since it is really easy to use and really quick for packing bitplanes. On a side note, I do all of my Unreal Engine project backups on disk and to a 48 terabyte NAS with automatic snapshots. There is no C++ code in my project, so in my opinion, no real need for source control, although some may argue that point. A typical project is 25 gigabytes or so I can easily get the last 40 build snapshots into 1 terabyte of drive space. On the 4 terabyte drive in my Xeon development computer, I maintain a backup folder and simply copy the Unreal project to that drive using incremental folder naming, plus a description of what was just completed. This way I can also reference builds at various stages of development. I have a fast WD SN850X 4 terabyte 7300 megabyte per second M2 drive in my Xeon, so creating the backups is fast. Plus it is 2.5 megabit networking to my NAS. If I used source control, then I would either have to set up a server here in my home or go through the speed limitation of the internet to a source control host. Each night I spend about 30 minutes performing multiple robocopy backups of my computer. That is it for this devlog. Stay tuned for part 3 next month.
Play. kills remain.
It has no escape. Our skill. Dominating.
5 kills remain.
Smell burning meat. Rocket scientist. Hunter becomes prey. Burning meat.
1 kill remains.
Die, enemy. Unstoppable.
Flawless victory.